Welcome back to Math 6. I trust you did a good job on the last assignment. Decimal numbers are exceedingly common in our lives, so being familiar with them is important. Problems number 30 and 32 on your assignment reviewed adding and subtracting whole numbers. They weren't intended to be hard. They were intended to help you remember those skills in preparation for today's lesson as we add and subtract decimal numbers. We're going to begin the lesson today by reviewing 3 important math properties you probably encountered in 5th grade math. When we add numbers together, there are certain facts which, by now, we recognize to be true. If they are always true, we call them mathematical properties. Here's one of them. Is this a true statement? Well, of course it is. If we actually do the adding, we get 11 on the left and 11 on the right, and 11 equals 11. But here's a question. Did we actually have to add these numbers to know that this was true? What if we had this equation? Is it true? Can you tell without actually doing the adding? Well, it is true. And we know it's true because when we add 2 numbers, we are going to get the same answer regardless of which one comes first. We have a name for this property. We call it the commutative property of addition. It basically says that the order of the addends can be changed without changing the sum. 3 plus 8 really does equal 8 plus 3, and it always will. Sometimes you'll see this property written with variables. You remember variables, right? A variable is a letter that takes the place of a number. We could write the commutative property of addition this way as a plus b equals b plus a. That a and that b can stand for any numbers we want, including decimal numbers. Again, the commutative property tells us that we can switch the order of the addends and get the same sum. That's the first property we're going to look at today. The second one is probably even easier. 37 plus 0 equals 37. What do we know about the sum when we add 0 to a number? The sum will always be that other number. We could just as easily have written 7 plus 0 equals 7, or 995 plus 0 equals 995. Whenever you add 0 to any number, you get that number. If we were to write that with a variable, it would look like this. A plus 0 equals A. The variable A, which can be any number, plus 0 still equals A. This property is called the identity property of addition. The third property is a little bit more involved, but it still isn't very difficult. It is also based on an important mathematical procedure that any time we have an operation inside parentheses, we should do that operation first. You'll see this in many other math lessons too. Is this a true statement? Let's take the time to verify it. On the left side, we do the addition in the parentheses first, and that gives us 15. And 15 plus 1 equals 16. Okay. On the right side, we do the addition in the parentheses first, and 9 plus 1 equals 10. And then 6 plus 10 equals 16. So yes, indeed, the 2 sides are equal to each other. Now the big question here is this. Will it always be true if we are adding up the same 3 numbers and we group them differently with parentheses so that different pairs are added first, that we will always get the same sum? And the answer is yes. And we call this the associative property of addition. Because it will always be true, we can show this one with variables as well. On the left, we would add a and b first. On the right, we would add b and c first. It won't matter. The sum will still always end up being the same. To help keep these straight, remember that the associative property changes the grouping, while the commutative property changes the order of the addends. Now, these properties are used in many ways, but let me show you one of them quickly. Doing mental math. Can you add these in your head? Quickly. Well, maybe you can. You would add 13 and 59 first and get 72, and then add 87 and 72 to get 159. But it's actually a lot easier if you regroup using the associative property. That would give you this, with parentheses around 87 plus 13. And what does 87 plus 13 equal? Well, that would be 100. And adding 100 plus 59 is easy. It is 159. So in this case, knowing the associative property would allow you to more quickly add those three numbers. Let's look at a few other quick problems related to these properties. For these next two, I'm going to show you two expressions, and I want you to think whether an equal sign or a not equal sign should go in the blank. What would you put here? Well, you should notice that the third number on each side is not the same, while the first and second are the same. The associative property demands that the numbers all be the same. So since one of them is different, this will be not equals. Let's look at a second one. There is no grouping, so this is not the associative property. It's the order that's changed. Without adding them together, can you tell whether the two sides are equal? Well, they are equal. Changing the order of the addends, according to the commutative property, does not change the sum, so the two sides are equal. We could even make this a fill-in-the-blank exercise, where you would have to put the correct missing number in the blank using these three properties. There are many ways we can use these properties, and you will see more of them as you learn more in your math classes. An important and frequently used skill in life is adding decimal numbers. We do it a lot with money, with small quantities of things, with times in sporting events, and many other things. Let's look at a word problem example. While on vacation, Eric went cross-country skiing on 3 different trails. The first trail took 1 7/75 hours to complete. The second trail took 2 4/10 hours. And the last trail took 3 8/10 hours. How much time did Eric spend skiing on these trails? Now, we are asked for a total time here, so it makes sense that we add these 3 separate times. But before we do, let's see what happens when we estimate his time. To estimate this, we should round each number off to the nearest whole hour. The first number, 1 7/75, should be rounded to 2. The second number, 2 4/10, will round down to 2. The third number has an 8 in the 10ths place, so it will be rounded up to 4. And these, of course, are easy to add. What is 2 plus 2 plus 4? That would be 8. Eric's total time should be somewhere in the neighborhood of 8 hours. We can also use place value pieces to illustrate this addition. Let's see what happens when we use those. The first number, 1 7/75, is shown with a single 1, 7/10, and 5/100. The other two numbers are shown with 1s and 10ths, but neither has any hundredths. Let's start grouping them together. Well, there are only 5/100. If we put the 10ths together, there are a total of 19 of them. Since 10/10 make one whole, we will replace them. We now have a grand total of 7 ones. This would indicate our total is 7 95/100. And that's pretty close to our estimate of 8, which is good. We still need to actually do this addition the traditional way, so let's get at it. Notice first of all that our decimal points are aligned in a nice vertical line. Anytime we add or subtract decimal numbers, this is an absolute requirement. Notice too that the numbers are written in nice, clear, neat columns. It's also a good idea when we have a problem like this one where the numbers end in different places to annex zeros so that each number ends at the same place. Once we have set it up neatly, it will be very similar to whole number addition. We start on the right, which is the hundredths column. We add 5, 0, and 0, and get 5. In the tenths column, we add 7, 4, and 8 and get 19. And renaming is just like with whole numbers. We write the 9 here and rename the 10 tenths as 1 whole. We then add the ones column. 1, 1, 2, and 3 add up to 7. So now, what are we missing? Ah, yes, the decimal point. It goes right in line with the decimal points in our addends. So our final answer is 7 95 hours. To give you some practice, I want you to try 2 of these. You will see them on your screen in a moment, so pause the program when they appear, copy them down vertically and add them on your paper, and then resume the lesson when you are ready to check to see if they are correct. You may also want to consider estimating your answers too. For this first one, let's rewrite it vertically. We should annex a 0 after that 2, and we can probably just write our decimal point in the sum now. So once you do all that, the adding is easy. Our answer is 8 866 thousandths. Now that problem had no renaming, but the other one did. We'll annex 2 zeros to our second addend and put our decimal point in its place. Everything else now is just like any other addition problem, and our final answer is 0 and 9,069 10,000ths. Subtraction is very similar to what we do with whole numbers. And, like addition, we align our decimal points and, if necessary, we annex zeros so both numbers end at the same place. Renaming will also be similar. Let's take a look at a word problem to help us see all of this. At a winter sports event, Eric watched skaters racing. During one race, the winner finished in 5 7/4 minutes, and the second place skater finished in 6 3/10 minutes. How much faster was the winner of the race than the skater who finished second? To find the difference between the times of the two skaters, we must subtract the shorter time from the longer time. Notice that when we write it, we align the decimal points. The decimal point in the difference will be in line with those decimal points. And before we go any further, we should annex a 0 after that 3. So now it's all set up for us. But first, let's try an estimate. We will round each number off to the nearest whole number. The top number, 6 3/10, becomes 6. The bottom number, 5 7/4, will round up to 6. And 6 minus 6 is 0. Does that really mean we get 0 when we subtract? Actually, no. It does mean, however, we should expect a very small answer, an answer that is close to 0 and probably less than 1. We'll keep this in mind. Let's see what happens when we use place value pieces to show this problem. Here we see 6 ones and 3 tenths. The first thing we have to do is subtract the 4 hundredths in our subtrahend, but to do that we must rename one of our tenths as 10 hundredths. Now we can remove 4 of them. We also need to subtract 7 tenths, but we can't do that without renaming either. So we'll take 1 1 and rename it into 10 tenths, and now we can take 7 of them away. Finally, we need to take away 5 ones. So after that renaming and subtracting, notice what we have left. No ones, 5 tenths, and 6 hundredths. Numerically, we write that as 0 and 56 hundredths. So is that the answer we will get if we do the subtraction in the traditional way? Let's find out. We'll start by putting that annexed 0 and decimal point back in as we discussed earlier. In the hundredths place, we have 0 minus 4, which demands a renaming. So we take 1 tenth and rename it as 10 hundredths. Then we can subtract 10 minus 4 and get 6. In the tenths place, we have 2 minus 7, and this also requires us to rename. So we take 1 from the ones place and add 10 tenths to the tenths place. Then we subtract 12 minus 7 and get 5. The ones place is pretty easy. 5 minus 5 is equal to 0. So our answer is indeed 0 and 56 hundredths of a minute. We can check these addition and subtraction problems by using the inverse operation, just as we can with whole numbers. If we added the difference, 0 and 56 hundredths, to the subtrahend, 5 and 74 hundredths, we will get the minuend, 6 and 3/10. You're welcome to give it a try. It would be good practice for you. And speaking of practice, I have 2 more problems for you to do. When they appear on the screen, pause the program, write them down, and work them out, and then resume the video to see if you got each of them correct. For this first one, let's write it vertically with the decimal points aligned. We need to annex a 0 onto the minuend, and then we can put our decimal point right down into the difference. Then the subtraction is similar to what we do with whole numbers, and our difference will be 32 and 604 thousandths. For the problem on the right, we also need to annex a 0 in the minuend. Sometimes, by the way, it is the subtrahend that needs to annex zeros. It could be either number. But let's put our decimal point in our difference now before we forget. And when this subtraction is complete, you should get 0 and 2,044 ten-thousandths. For the record, if you want to check either of these answers, you can do so by adding the difference and the subtrahend together, which should and will equal the minuend. Always remember to keep those decimal points aligned and to write neatly. I have seen far too many mistakes that resulted from sloppy writing, so be careful when you do problems like these. Your assignment for this lesson is to do the even-numbered problems on textbook pages 12 and 13 up through number 40. In the first group of 19 problems, notice that they go back and forth between addition and subtraction, so be careful to do the right operation on each of those. For problems 14 through 19, notice that 2 estimates are required. On number 14, you might get confused because to round to the greatest place is actually the same as rounding to the nearest whole number, so remember that. Now basically, your 2 estimates for that problem will be identical. For problems 24 through 32, you are to use 1 or more properties to make the numbers easier to add quickly. You may want to focus on that word easier. What can be done to make these easier to add? Number 38 is a review question, and simply means that you are to count by 9s, starting at 9, then 18, and on up to 90. I'll let you figure out all the numbers that go in the middle. Let me remind you that the information at the top of both page 12 and page 13 is there to help you remember what was discussed in today's lesson. Unless you are going to start the assignment in the next 3 minutes or so, it would be a good idea to review this information before you start the first problem of your assignment. There are reminders there about rounding to estimate and about which property is which. Don't ignore that information. It could be helpful to you. Have a great day and enjoy your learning.